we're 4.3 to 7 practice quiz. I think number 1 has a third x cubed plus 3x squared. Is that the sheet you're looking at? Yeah. So we can do a second sheet of this for tomorrow, but that's all I own. So I gave you that second sheet. Does that seem like a thing you'd want to do a second sheet, right? Yeah. So that's out there. So today we need to be productive. Tomorrow we need to be productive, and then I just kind of run out of materials. So we're off. 1, what's your first thing you want to do on 1? Do the derivative. And then once you've done the derivative, what do you do to that derivative? Factor it. That gets you what 2 numbers?
-4, -2.
Agree with -4 and -2. Then what else do we have to do? Second derivative. Factor that. Gets you one more number.
-3.
-3. So from left to right, we're going to go in order: -4, -3, -2. Anybody bothered by that? Then how did your increase decrease pattern go?
Increase, decrease, decrease, increase.
Agree. Increase, decrease, decrease, increase. How did your up downs go?
Down, down, up, up.
Down, down, up, up. I agree. Does anybody need the increase, decrease, and the up downs? We're imagining numbers and we're plugging them into the factored areas. The first derivative gives you that increase, decrease. And then the second derivative gives you the up down when you're using imagination numbers in the gaps. Anybody need guidance with that? Okay, then we go to get y coordinates. How do we get the y coordinates?
Plug into the original.
Plug into the original thing. So who is -4's fraction or mixed number buddy?
1 2/3.
1 2/3 or 5/3. -3 has a whole number partner. 1. -2 has a fractional partner, 1/3. I'd agree. And then we make some shapes and play connect the dots with the shapes. It should look something like this. This touch point right here is 7 squares above the origin. That wasn't a point you had to find, but it's an easy enough point to find. It might be worth finding it. If you plug 0 into the original, you'd get out 7. So there's a touch point on the y-axis that's 7 above. This very nearly scrapes the x-axis, but not quite. I have no idea where this would touch the x-axis. It would be kind of a drag to figure that out. Question about 1? 2, we do about the same thing. First derivative gives you what 2 magic numbers?
1 and -1.
1 and -1. Second derivative gives you which 1 magic number?
0.
0. So from left to right, -1, then 0, then +1. It's going to go increase, decrease, decrease, increase. It's going to go down, down, up, up. And it's going to give you this pretty much exact same kind of thing. It's going to clip the origin right about here. The mountain here is 1 high. The valley here is 1 low. I have no idea what numbers it crosses the x-axis farther left and right, because those would be kind of a pain to figure those out. I think the x might, yeah, I don't know. That's going to be a pain. I don't know. Question about 2? The y's. -1 partners up with +2/3. +1 partners with -2/3. And then 0, 0. So I think I said those were 1 high. That was a slight fib. They're 2/3 high. It's the mountains and the valleys. Question about 2? Okay. 3. Let's do all the vertical asymptotes first. How do you find the vertical asymptotes? Whatever makes the bottom equal 0. So number 3 doesn't have 1, so you could do the traditional no answer symbol for vertical asymptote on 3. 4 would be what number?
3.
3. 5 is a fraction. -9/7. 6 is a whole number.
-3.
-3. Question about vertical asymptotes. How do you do horizontals?
It's approaching infinity.
Limits as x approaches infinity. So if the top has the bigger power, Say it again.
Impossible.
Impossible. If the top and bottom tie,
Fraction.
make a fraction. And if the bottom's bigger, that's the easiest. It's just 0. So 3's horizontal
0.
is 0. 4's horizontal,
Impossible.
impossible. 5 is a fraction, 2/7. 6,
Impossible.
impossible. Question horizontals. Slant is the least likely. You're only going to have a slant if the top is bigger in power by exactly
1.
1. And if it is, you have to like divide it in one way or another. So 3 slant,
Nothing.
nothing. If you have a horizontal, you can't have a slant. If you have a slant, you can't have a horizontal. Those are exclusive. If you have one, you can't have the other one. 4,
Nothing.
nothing, because the top's bigger by 2. 5,
Nothing.
nothing, because you had a horizontal. 6 is the only one that has a slant. You could either long divide or synthetic divide. I like the synthetic divide, but you do you. Thought? It is x plus 2. Question about the asymptotes. It's a weird page to grade. I made these 2 points apiece somewhere back in time. There's 5 answers for 2 points. So I make each answer 0.4 points, and then I just like round it to the nearest half point, like wherever it ends up settling in. Dominant term large is easy, most of the time. Dominant term large, you can just copy from who? Slant, maybe, if we had it. If we don't have a slant, you can still copy the horizontal. The only way you're going to have to do any work is if you got shut out on horizontal and slant. If that happens, then what do you do to get the large? You divide by some means. So 3, divide or copy?
Copy.
Copy, it's
0.
0. 4,
Divide.
divide. I'd synthetic divide, but again, you do you. Somebody with starts with 4x squared.
4x squared plus 17x plus 57.
That's a win. 5, 2/7. 6, x plus 2. Question on those.
What was 4's?
4's was 4x squared plus 17x plus 57.
Okay.
The dominant small you have to work on by dividing. Except for 3. Why don't you have to divide on 3? Why can't you divide on 3? The bottom has the bigger power. So the dominant small is
0.
no,
Impossible.
no. Copy the problem. The whole problem itself. Just keep it. So dominant small is 2x plus 7 on top of x squared plus 12. 4, we already divided. How does dividing give us this small dominant term?
Remainder.
Remainder. 180 on top of
X minus 3.
x minus 3. 5, you're going to have to go through the dividing process. It's going to be a pain. My dominant small, I have 3 on top. And on the bottom, I have a 7 because the remainder was 3/7. And the 7 either can or can't distribute the 7x plus 9. So 3 on top of 7 with the 7x plus 9 in parentheses next to the 7 wanting to distribute or actually being distributed is the way to go there. And I can divide 5 if you need me to divide 5, but nothing that really used the board yet. 6 we divided already. The remainder should be 1 on top of x plus 3. Does anybody need me to divide 5? Yeah. So bottom always goes out. Top always goes in. When we're long dividing, it's always this divided by this. Just focus on the leaders. This 2x thing dividing this 7x thing would cancel x's and get 2/7. You with that so far? This has to distribute, so 7's would cancel, so a perfect 2x match, plus multiplying here, that is 18/7.
Okay.
You with that? Change 3 to make common denominator to be 21/7. And that'll get you the 3/7 that I referenced a second ago. You with that?
Yeah.
Then don't, usually what we do is remainder on top of divisor. But like that is too ridiculous of a stack of fraction would. So this in parentheses can just go be with its friend.
Okay.
I distributed mine, but you don't have to. I just like to show off. Anything up through 6?
So you can write that either like that, like the fraction outside of the parentheses, or 3/49x plus 62.
Yeah, we'd either want to go 3 on 7 distributing,
Yeah.
or 3 on 49x plus 60.
Okay.
Just we don't want to have it like I circled it, because
Yeah.
that's too weird.
I had the right answer.
It does look a little bit like a Christmas tree though, in the holiday season.
Yeah, see, that's
It's
why.
a little bit Christmas tree shaped,
You judge my method scaling.
a little bit.
That makes the triangle.
Anything up to 6? 7, we continue on the tradition of what we were doing here. So vertical asymptote is 0. Horizontal? No. Slant? X. Dominant large is therefore X. Dominant small is 1/x. 7, I'm doing the dividing by just separating it into 2 fractions. The thing that isn't a fraction long term is the large, the x. And the thing that does stay a fraction, 1/x, is the small. And then we're going to sketch a graph for this. So what we have going on here is a vertical asymptote that I can't draw because the axis is in the way. I have a slant asymptote. Y equals x is a straight line that splits those quadrants dead in half. So I can do that as a little bit of a guideline. And that was the dominant large. So I'm going to try to get close to this on the far extremes. Far right, far left. I'm going to want to be not touching that line, but getting really, really close to it. Then there's some graphs from a book page that I forget what page it is that you want to memorize. You want to know x, x squared, x cubed. You want to know 1/x, you want to know 1/x squared. Does anybody remember what 1/x was about?
It's like the.
Yeah, it's going to fill quadrant 1 like this,
And 3.
and it's going to fill quadrant 3. If I made that squared, all it does is that the negative becomes positive, and we fill those 2 quadrants like a funnel upside down. I want to get close to that when I'm in tight, close to 0 origin axis like kind of areas. So dominant smalls we want to get close to on the inners, and dominant larges we want to get close to on the outers. And if we're going to try to resemble them but not touch them, I'd have to squeeze something like this in there. I'd have to squeeze something like that in there. And I would tell you page 1, page 2, and this page. Anything that you've graphed, just use your calculator graph feature to make sure you graphed it right. If you graphed it wrong, it's not fair to use your screen to cheat on a new graph, but it is fair to recognize, uh-oh, my graph is wrong, and try to figure out where it went wrong. Or to give an acknowledgement of, I know I'm wrong because I graphed this. I'd probably give you points just for catching your own mistake and just saying like, I know my graph is wrong, I can't figure out why. Give me a pity half point for checking it on the graph. I'd be on board with that. Something up to 7. 8. All right, so 8. It's hard to tell you exactly what to do because different people are going to make different style choices. So my first style choice was, first sentence, I wrote x plus y equals 48. You might not have used x and y. That's okay, but it'll make it harder to converse. That only exists for you to do a substitution. I made mine x equals 48 minus y. You could have done yours as y equals 48 minus x, or maybe you have different letters entirely. But where we should all agree is letter plus letter equals 48, and substituting, we're going to use one letter equaling 48 minus another. That we should all sit there. Then the equation we're doing the derivative of is always an equation that uses a word like large or small or biggest or smallest or something like that. So I have an equation something like one letter squared plus the other letter squared. And then I made a substitution because I can't do the derivative and solve it if it has two different letters. So what I have is, in my world, y squared plus 48 minus y in parentheses getting squared. That's what I'm going to do the derivative of, but it's going to take me a minute. I'm going to FOIL that out. I'm going to combine like terms. I'm going to get that shrunken down. Then I'm going to do the derivative. When I did my derivative, I got 4y minus 96. I think no matter what letters you did, you should settle in there with 4 times some letter minus 96. Does anybody need some help to get there from where I left you? So that gives you away a magic number of 24. 24's partner would unsurprisingly be 24. But you don't know if that's the most or the least that you could do. 24 partnered with 24 might be the max, it might be the min, we don't know. What would be a way that you could settle that dispute?
Second derivative.
We could do the second derivative. Second derivative would be positive 4. Positive second derivative means it's concave up, which concave up shapes have a min. So if I asked you for the min, 24 would be the min. Unfortunately,
And you asked us for the max.
I asked you for the max. So there's another sneaky number in play, because if you remember this lesson, we had to always stay in bounds. There is a boundary. What's the boundary number? 0. What word caused that boundary? Non-negative caused 0 to be a boundary number. Who is 0's friend?
48.
48. That's the max. If you want to check it, you could go 0 squared plus 48 squared, and it's little, compared to 24 squared plus 24 squared, which is bigger. You could also not have done the second derivative at all. You could have just picked any other number between like 0 and 48, like 5. 5's partner is 43. 5 squared plus 43 squared is going to always be kind of like medium sized. 0, 48 is going to be littlest. 24, 24 is going to be biggest. Question about 8?
So that answer.
0 and 48. Anything 8? Next sheet will have these 3 problems. The quiz will have these 3 problems. The practice test will not have these 3 problems, neither will the test. The practice test and test will go and dip back into that page and do a whole different selection. But the quiz, all the quiz preps and the quiz, I'll do these 3. 9, we got the boxy box. So your equation should be a 12 minus 2x, wanting to FOIL out with an 18 minus 2x, wanting to distribute an x. That's where we need to come in. If you didn't come in there, you might as well just stop listening, because nothing's going to be agreeable to you. But we'd have a 12 minus 2x side, an 18 minus 2x side, and an x coming out of the page at you. Question about how I settled on that.
Where is this that X coming from?
The x is the corner. So we have a sheet of stuff that's 18 by 12. and out of every corner I cut out x's.
Yeah.
Because we don't know. Okay, so experiencing technical difficulties, hopefully we didn't miss too much valuable information, but where we were on 10 that maybe didn't record is we had a foiling problem and we substituted, and maybe it was 8 times a letter plus 800 letter to a -1 plus 160, or maybe it was 10 times a letter plus 640 letter to a -1 plus some other number that I don't know because I didn't do it that way, but it doesn't matter because the derivative would have wiped it out anyhow. So the way I did it, my derivative is 8 minus 800 over letter squared. If you did it a different way, you could have had 10 minus 640 over a letter squared. Algebra solving that should get you a 10 my way or an 8 the other way. But it doesn't matter because the 10 leads you to an 8 and an 8 leads you to a 10, and it's a rectangle, so what difference does it make? Because when you have a rectangle and you get a little bit too obstinate about which way is up and which way is sideways, and somebody just goes like this, you feel kind of dumb, not the whole thing, but it is what it is. But 10 and 8 are the letters we've been hunting, but that isn't the answer, because the answer isn't about the printed space. The answer is about the poster in totality. So we need to do the 10 plus its 10-inch margins is a 20, and the 8 plus the 8-inch margins is a 16, and that's the win. I talked for a while and didn't really ask for
Wait.
questions. Go ahead.
Isn't it 5-inch margins? Or top
Two
and bottom,
fives.
so double it.
Yeah, two
never mind.
5s.
Never mind.
Okay. Any trouble with 20 by 16? Future generations might be thinking, please ask a question, I didn't get that. Too bad for them. They should have been as smart as the 2025, 2026 year, I guess. Anything up through 10? Then you turn the page and it's like a breath of fresh air.
It's light at the end of the tunnel.
So much easier. Such a good page. Remember to do either plus C plus C plus C plus C plus C, or some sort of a ridiculous thing like this that fills up your whole page with a C for everybody.
That's not it.
Everybody gets a C. 11, I'm saying 2x squared. 12 is a 1/8 x to the 8. If you forget how to do that, the power first needs to do what? Go up by 1, and then out front, we're going to divide by the new power. 13 is just sine x. 14, you'd have to do some rewriting as fraction powers. I'm going to go with an answer of 2/3 x to the 3/2 minus 2x to the 1/2. 15 is 9/20 x to a 5/3. Remember on this, when you divide fractions, that you flip. 16 is 1/9 x to the 9 minus 2x to the 3 plus 5x. 17 has a half in front because we need to divide by the derivative of the 2x, which is a 2, so a half to the front, and then secant 2x. Do you need any help on those?
What was 15?
15 was 9/20 x to the 5/3. You need a help or how?
Yeah.
Okay, so we're going to go power up by 1. So with fractions, the simplest thing to do there is add bottom to top. So that's how I created the x to the 5/3. Then I'm going to divide by that new power, which is going to flip that 5/3 into a 3/5. And 3/5 is going to go multiply out front with the 3/4, and I'll multiply straight across 9/20 kind of way.
Okay.
There's another voice. Was it that question or a different one?
It is the same.
Same one, okay. Anybody that page need guidance? Okay. 18, I'm going to rewrite these with negative powers before I go at them. After I do, did I change the middle one? Instead of being 8 over x, did I make it 8 over x cubed?
Yeah.
Okay, because if it was 8 over x, you can't do that till chapter 6. Because the
Nice.
-1, that would be a -1 power, which would rise up to
Zero.
0. And then you're trying to
Divide
by
0.
0, which is bad news. So that's a chapter 6 concept. It involves logarithms. Spoiler alert.
Oh.
18, we're going to go -6x to the -1 minus 4x to the -2 plus 7x plus c, as always. 19 is 5x minus 2 cotan 4x. If you make a co out of these, the sign's going to flip. 20 is 2x cubed plus 7/2 x squared plus 3x plus 6. Word of advice there, I only use 3 of the trig ones. Make sure you know all 6 of the trig ones. Sine, cosine, tan, cotan, secant, cosecant, all could be in play. Anything up to 20? 21, I make a 2-point question because it's like a 2-step process. The first thing you'd have is a 7x minus half x squared with a plus c temporary. And then you try to use algebra to figure out the c. And I was kind to you and gave you a 0. And the c is quickly unveiled as a -3. So the total answer isn't just the -3. It's all of the stuff I just said. It would be 7x minus half x squared minus 3. Put it all together. 22, you'd get a point for getting 3/2 x squared plus cosine x plus c. I'm kind of kind to you with the 0, but kind of deceptive with the 0 because the cosine of 0 is 1. So the c isn't a 5, it ends up being a 4. It's 3/2 x squared plus cosine x plus 4. Something there. 23, I make a 3-point question because there's 2 rotations. So the first derivative would be 3x minus 4x squared plus a c, and the c unveils itself as a 6. Then we go again, and we get 3/2 x squared minus 4/3 x cubed plus 6x, because the 6x built off the 6, plus a new c. And the new c is a fraction. Anybody think you have it?
5, 6.
It is. So grand total is 3/2 x squared minus 4/3 x cubed plus 6x plus 5, 6. How'd I do what? Okay, so you have the 3/2 x squared minus 4/3 x cubed plus 6x plus c? Okay, so then I have 7 equals 3/2 minus 4/3 plus 6 plus c. And then 7 minus 6 is 1. 1 adding 4/3 is 7/3. 7/3 minus 3/2 is like common denominator time with 6's and changing tops. Is that okay? Anybody else, anything?